Our next example deals with maximums and minimums. Okay, it's an optimization problem. It's found on slide number 7 in the 2.6 PowerPoint presentation. So you have this local newspaper, and the production cost is what? C of X, or C, is equal to 55,000 minus 108X plus what? 600X squared. Okay, C is total cost in dollars, and X is the number of newspapers. How many newspapers should be printed each day to yield a minimum cost? So if we're looking for how many newspapers, and X is the number of newspapers, all we need to do here is understand that the vertex of a parabola is going to either be a minimum or a maximum. In this case, because our C value, or excuse me, not our C value, because our A value is greater than 0, then you'll have a minimum at the vertex. Because the leading coefficient, because the A value is greater than 0, okay, then you're going to have a minimum at the vertex. So again, look at the actual question in the PowerPoint. All you have to do to answer this particular question is to solve for X. All right, the X coordinate in that vertex point. So we know that the X coordinate of your vertex is always negative B over 2A. So it's going to be the opposite of negative 108 all over 2 times the A value, which is always the coefficient of X squared. This is written in ascending order, so be careful. This is your A, this is your B, this is your C. Anywho, put the A down below in the denominator, and you get what here? If you simplify this, you get a positive 900. And so how many newspapers should be printed each day to yield a minimum cost? 900 newspapers should be printed. If I actually wanted to know the minimum cost, what would I do? I would plug in 900 into my cost function, but that's not what the question is asking for. Okay, this is how many this should be printed to yield a minimum cost. The actual minimum cost, again, will be determined by replacing every X with this amount. Okay. All right, our final example from the PowerPoint presentation, section 2.6, is found on slide number 9. This deals with market equilibrium. Okay, so if you studied the PowerPoint presentation, you know from the previous slide that market equilibrium is when supply equals demand. All right, so we have our demand model here, and we have our supply model here of this Titan Tire Company. All right, we're looking at the weekly demand and the weekly supply function for their Super Titan tires. All right, so to solve this, you will do what? Well, again, market equilibrium is when supply is equal to demand. So because that's the case, we're going to let P equal P when supply is equal to demand. All right, so very similar to what we've been doing thus far, we're going to let these two expressions in terms of X be equal to one another to ultimately be able to solve for X and determine our market equilibrium. Okay, so how do we do this? Well, I'm going to subtract 48 from both sides. 144 minus 4, I'll just go ahead and show you that. I'm going to subtract 48 from both sides. And I'm also going to be adding X squared to both sides. And so you get what? You get 96 is equal to what? 3 halves X squared. Okay, again, I'm trying to isolate X at this point. To get rid of the 3 halves, I'm going to multiply both sides by the reciprocal of 3 halves. I'm multiplying both sides by the reciprocal of 3 halves. I'm doing that because on the right, notice this all cancels and you're left with just X squared, okay? On the left, 2/3 of 96 is 64. So we now have X squared equaling 64. So if you take the square root of both sides, and remember, you recognize it's quadratic, you're going to get what? Look, you get X squared equals 64. You take the square root of both sides. Remember the plus or minus in front here, because it's quadratic. You get X equals plus or minus 8. All right, now with that being said, you're not going to have a negative number of tires, even though that this is technically correct. You do just get 8, okay? You're going to look at the principal root here in this situation because it's a real-life application type scenario, All right, we're only looking at quadrant number 1. Okay, so you do get 8 for x. And if x is 8, how could you figure out the corresponding p-value, which is price? Well, plug it back into either one of the original functions. So if you get 8, let's see, let's use p equals 144 minus 8 squared. I just replace this x with an 8, and you get what? I believe you get 64 to 80. Okay, so now before I go any further, I need to remember. First of all, I got to read the question. I got to understand that P represents price in terms of dollars, okay? X represents the quantity of tires in units of 1,000. This is important. So this really is not your final answer. This is measured in units of 1,000. So therefore, your equilibrium point would actually be 8,000 tires. All right, that's the X portion of this, which would give us an equilibrium price of $80 per tire. Okay? Study that PowerPoint presentation on 2.6, and hopefully these examples will make more sense. All right. Take care. Bye-bye.